Hello, in this video I'm going to be talking about categorical data. Now, we've already seen that when we're trying to predict something that is numeric, we're generally going to be using a regression. And when we're trying to predict something that's categorical, we'll use a classification. And the things we learned for that so far were linear regression and logistic regression. Now, in this video and in the next couple of following, I'm going to be tackling a new problem, which is what if an input variable is categorical? It turns out that regardless of whether we're doing linear regression or logistic regression, we're going to need to have numeric inputs. And so what we're going to do is use something called one-hot encoding, convert categorical data to numeric data. And so we won't get to that in this video, but we're going to be building towards that and motivating it. So the data I want to work with in this example is a data set from the city of Chicago that they have about monitoring waves on Lake Michigan in various Chicago beaches. And there's 6 beaches that they have. And so I've already downloaded this data from here. It's in a file called waves.csv. And I can look at it, and I see there's a bunch of stuff like the temperature and the wave height, which is what we're going to want to predict. And what I'm going to try to do is predict wave height based on wave period initially. And then eventually I'm going to add in this other factor, this categorical data, which is the beach name. Okay, so right away, what I'm seeing is that since I'm predicting wave height, that's numeric, I'm going to be doing a linear regression on this data. Okay, so the first thing you're often going to want to do on a project is do some basic plotting and get a feel for it and gain some intuition about how you might want to build your machine learning pipeline. And so I'm going to do that. Maybe one of the first things I do is I do a scatter plot of the thing I'm trying to predict and the thing that it's based on. So let's say I plot the wave period, the time between waves, the x-axis, and then I'm going to get this wave height on the y-axis. And I do that, and I can immediately see that the data is pretty dirty, right? I can see that there's not such a thing as really a negative height for a wave. And since I have these values down here that it's like negative 100,000, that's messing up my whole plot, right? There's actually a bunch of variety up here that's kind of getting squished. So one of the first things I'm going to do is I'm going to clean up my data, right? And so how am I going to do that? I'm going to say that I want to make sure that I'm only looking at data where these things are positive, right? And this is one of the reasons to plot beforehand, right? I mean, I could have gone ahead and done some machine learning, and it might have learned something, and probably what it learned is when data is missing, well, I mean, what is the wave height, right? I probably learned some nonsense, right? So I want to make sure that the wave period is greater than 0, and really just to be safe. I think that's actually probably enough. Let me just try plotting that. The wave, well, you know what I'm going to do. I have to say data frame equals that. That's more reasonable, but just to be safe, I want to make sure that both of these important variables are positive, right? So I'm going to grab this too. And there we go. I want to make sure that this wave height is also positive, just to be safe. Okay. Now when I'm doing this kind of scatter plot, right, there's a lot of points on top of each other. A perfect opportunity to set an alpha, transparency. Maybe what I'll do is I'll set the color to be black and the alpha be, I don't know, 0.05. I can actually see something there. And so at this point, I'm going to actually make an observation. And my observation is that this is a non-linear relationship. Right? For linear, I can imagine fitting some sort of straight line to this data. The higher the wave period, the higher the wave height. But I don't see that. I see a time goes up and then comes back down. Maybe kind of like a quadratic formula, right? Where the coefficient on x squared is negative, right? So the implication there, right, is that I'm going to use polynomial features later. Okay? The other thing I want to do is I want to see if the beach I'm looking at matters, right? Should I be trying to just do this overall, or should I be going by the beach? So maybe the first thing I'm going to do is I'm just going to grab the different beach names, see how many beaches we're dealing with. I'm going to say beach names equals data frame of beach name. And I want to get that as a set. Do that. Beach names. And you know what? Let's just make this a sorted list. Just like that. And great. So these are, I can see there's 6 beaches I'm dealing with. And so immediately, right, any plot that I have, like for example, a scatter plot, it's better if I can give more context and show, is this a trend overall, or does it vary by subcategory? So this would be a very natural place to use subplots, right? So I can show different parts or show the pattern for different beaches. And so I'm going to do exactly that. I am going to do plt.subplots. Did I import plt already? It looks like I did. And since I can see there's 6 beaches, I'm trying to figure out how I want to do this. Maybe I'm going to say there's like 2 rows and 3 columns, something like that. And I see this is returning a figure, and then these axes, right? So let me just do this. I'm going to say fig axes equal that, and let me look at these axes. Here I see it's a 2-dimensional array, right, of these axes. If I look at the shape of that. And so maybe what I'd like to do is just say reshape. I just want it 1-dimensional, however long that needs to be. And I'm going to put that in a list, right? So I'm going to do this. And the advantage of doing this is that I'm going to loop over these beach names. And for each one, I'm going to pop off one of these axes subplot regions and actually use it to do my plotting. Okay? That's what I'm heading towards. And let me make this a little bit larger, right? So maybe I'm going to do like a 12 by 8. That's, I have a little space. And so at this point, let's loop over the beaches, right? So I'm going to say for B and beach names, I'm going to get a beach data frame, which is going to be my original frame, where the beach name is that. Okay, and then I want to plot that one in an AX. So maybe let me just do the same plotting I did before. I do this thing like so, but instead of that, I'm going to do beach df, just like that. And then I have to say, well, if I do this right now, they all are going to go to the same one. Actually, no, they all go to new ones, which is not great. I would like to use these existing ones that I have in this nice list. So I'm going to do this. I'm going to say AX equal axes pop 0, right? So I'm going to be going kind of row by row here over the subplots. I'm just going to pass this in right here. And I do that, and I can already see I'm getting the different beaches in this figure, right? Now there's a few more things I should probably do. One of them is that I would like to know which beach is which, and so I'm going to say ax.set title, and the title is, well, B, right? Over the beach names. I'm going to do that. Now that's a little bit crowded, and so I need to adjust the space between these, and I am going to do that with my notes here. The subplots adjust function, right? So right here, after I do this, I'm going to say plt subplots adjust. I don't have this memorized, right? I'm just trying to checking my notes here. That's kind of a fine thing to do. And then there's like the height space. So I'm going to say height space is 0.3. So 0.3 of the figures is how much space I'm going to get between these. And now that's actually kind of looking pretty good, right? I can see these not overlapping. Now, to make it easy to compare across these, notice that they're all kind of on a different scale right now, which is not great. And so what I should probably do when I create this is I should say share y equals true. And so now they're all on the same scale, and I can actually compare across different beaches, right? And maybe let me just crank this up for a moment. You can see that some of them have these really outliers, whereas a very high wave day, right? That's kind of what's scaling it. Let me just put this back down, and I can see that some of these beaches are pretty similar, right? So, for example, Montrose Beach up here looks very similar to Osterman Beach, but other ones look pretty different. For example, especially this one right here, this Calumet Beach, hopefully I'm pronouncing that correctly, has a very distinct pattern than the other ones, right? So maybe if I was making observations here, right, observation, beaches have distinct patterns, and that's going to have implications for how I'm going to do my machine learning, right? What am I going to do? So before I saw, hey, I want to use polynomial features because there's this up and down thing. And this one, I'm going to use something called one-hot encoding to deal with the categorical data. I may actually introduce which beach we're on to kind of factor this in. Okay, so now I'm ready to start setting up my machine learning pipeline. And so I'm going to head down here, and there's a bunch of stuff I have to import from sklearn. Like I need to get my pipeline object, and well, looking back at what we're trying to predict, right? I think we made the observation earlier that we're doing regressions, right? Because this is numeric. So I'm going to down here. I am going to import a linear regression. And then we want some metrics, right? So I want to, from metrics, a nice metric that's going to give us a 0 to 1 score is the amount of, let me try to remember what this is. This is the explained variance. You know what? And I'm not remembering it. So what I'm going to do is I'm just going to import this like so. And then I'm going to just do a dir on it. I don't even have to go look up the documentation right now. I'm predicting exactly how to spell it. And the demo manages to get worse. What am I doing here wrong? This is on line 1. Oh, you know what? From this, that's probably why my autocomplete wasn't working. And I wanted the explained variance score, which is somewhere. This is the one I was looking for. Okay, so I want to grab that one, right, to evaluate how my linear regression is doing. I'm going to do that. That's all good. Goodness, more mistakes. Okay, we're actually making our way there slowly but surely. Let me now create my pipeline, and then what I'm going to do is in this video I'm going to show how taking this first observation into account works, and then we're going to have a break. And in the next video we're actually going to show how we're going to do this one-hot encoding. And so what I'm going to do here is I'm going to create my pipeline, and a pipeline is a list of steps, and those steps might be some transformers, and I'm actually eventually have 2 of them, right, for my polynomial features and my one-hot encoding, and then it's going to end right after the transformers. I have to have an estimator, and the estimator is my linear regression. Just like that. And the trick is, right, I can't just put these different kind of modules in here. I have to give them names, and I do that by passing in a 2-tuple, right? So you'll just call this linear regression. That's what is expected for a pipeline. And okay, at this point, right, I actually want to do my work, right? So I'm going to say x columns equals, I want to know what beach name is, and I want to know what the wave period is, and then what I'm trying to predict, right, is the wave height, right? So let's try doing this. I'm going to say p dot fit, and what am I fitting to? Well, I'm going to have some training data, which notice I haven't actually created yet. I do my x columns, and then I'm going to have my what I'm actually predicting, right? So, and of course I don't have my training data yet. So let me do that too quickly. I'm going to say from sklearn model selection import. I need to have this train test split. Just like that. And let me actually do that. So train and test data is going to be from a train test split on my data frame. And I'll just peek at this again. Okay, I'm going to come down here, and so it's always helpful to notice when we're making progress, right, on our bug. I got a different error, so that is progress. And what is it complaining about? Can't deal with this categorical data yet, right? It doesn't know how to convert that string to a number, and eventually we will do that, but it's trying to create some work on our part. So at this point, I'm just trying to do it directly on that wave period, right? So I do that, and then what I'd like to do is I'd like to evaluate how well that works. And to do that, well, what do? I need to call predict, right? So I need to make a prediction based on my test data, right? My inputs. I'm going to do that. And are these good or are they bad? Well, to find out, I need to feed it to one of my metrics, right? And for my metrics, I've been using this explained variance score, right? So that was what is predicted, and I want to compare that to what is actually the truth, which is whatever is in that y column. And I can actually see we're doing horrible, right? We got a negative score. So after doing our linear regression, we did worse than if we had just kind of taken the mean as our only number. And so let me add this here, right? So I'm going to do this. What I would like to do is I would like to also run this on my training data, right? In the end, right, the test number is more meaningful, but comparing these two numbers can tell us something. Right, I see both these numbers are small, so that doesn't mean I really have any worry about overfitting. It's just that simply I cannot fit a straight line to this pattern very well. And of course, we knew that, right? We saw earlier that we're going to want to use some polynomial features to kind of get not a straight line, but that quadratic up and down. And so what I'm going to do here, right, I had that as a to-do. I want to add some polynomial features. And so I'm going to add those polynomial features like that. And let's have a second order. And so I run this again. And you know what? I think that the problem here is that I didn't import that yet. So I can say from sklearn.pre-processing, I want to import polynomial features like so. Now let's actually give this a try. And this is much better, right? So I mean, now I'm getting to about 5%, 4.5%, I guess. And I don't have any signs of overfitting, right? I mean, that kind of works well on both of them. Out of curiosity, let's just see what happens here. Right? See, it was a much smaller number, right? So it was like a fraction, 1% or even negative, right? So this is definitely helping capture that pattern, even though this is not an amazing score. Like 0.9 would be an amazing score. Let's see what happens if we increase this further. There doesn't seem to be much harm in doing that, right? Just trying to realizing it doesn't need that. So I'm just going to leave it here, right? Keep the model. One is no good, but having second order polynomials is helping, right? And so that's good. And so I've done this one part, the poly part. And then just by looking back at this, I can see in the next video, I'm going to have to take the beach into account. And when we do that, we're going to be getting up close to 10% instead of 4.5%.